Hey everyone, welcome back to Coursera. Today we are again back with another problem solving video. So today, instead of solving just a single problem, we will be going up with solving three problems. Although all three of them are of similar type, but still we need to find the solution for each of them. There is a bit of difference between all of them. So that's how we will be approaching up. So now let's get into the problem statements. So today's problem, all three problems are on LeetCode. We take you there, and these are the problem statements which we have. So one is power of 3, one is power of 4, and one is power of 2. Here we are. So these three problem statements will be in front of us. We have to find a solution of each of them individually. But even if we're able to find the solution of one of them, we can relate and we can find the solution for others also. So now let's get into it. So power of 2, power of 3, power of 4. First of all, we'll be taking off the screenshot just for the power of 2, trying to solve it off in our OneNote basically. And then you know, the coding solution basically. So problem statement is power of 2, and what we get from it is we will be given up an integer and we have to return true or false, and we have to return true if it is a power of true, or otherwise we have to return false. So let's take screenshot of all three of them. So this is power of 3 problem statement. Problem number is but here will be power of 3. And now let's get into the last one, that is power of 4. Here we are taking off the screenshot. Here it for the power of 4 answer. So these are three questions on power of 2, power of 3, power of 4. These are the four problem statements which we have. And now let's get into it, how we can solve it up. So here you can see that there will be a lot of similarity between each of the problem statements. And we have on the end, on the basis of those similarities only, we can just write a simple code which can work with just of the few here and there for all of them. So we will be given up an integer. Let's suppose that integer is n. So int n will be given to us. And if it is a power of 2, and if that we have to return true if it is power of 2 or 3 or 4. So it will be like if the problem statement, the n, which is given to us, is somehow a power of 2. If 2 raised to power x is somehow equals to n. Anyhow, any power, any x. They didn't ask for x. We didn't need to find x. No. We just need to find whether it is or not. If it is, we have to return true. If it is not, then we have to return false. And same we have to do for every one of them. But this also for the so problem statement is quite easy. These are also of easy level. That's why I took three problem statement instead of just going for the one. So what we can do is, first of all, in the problem statements, we have to return bool only. So I will be writing a condition if my n is equals to 0, then directly return false. And then why we need to return false? It is because we need to return if it is like a factor of, or we can say the power of 2 or power of 3 or power of 4 somehow reaches there. If we if our n is 0, then we reach for sure not. That's why we have to do return false at the beginning only, just to counter the edge case or the base case, and then we have to next figure out for the other statements. So for that we will be using a while, and how this while loop will be working off is while our n is divisible. So what we will be doing is we will be dividing n till the end, whatever the n will be given to us. Just suppose for the example will be of 60, and we have to find whether it is for 2, like 2 raised to power x, somehow it reaches 16 or not. Then we, in the while loop, we will be dividing it again and again till it is actually divisible by. So while our n, or we could say n modulo 2 is equals to 0. And what does this mean is our n divides 0. It is just like it is check if it divides our n by 2 completely. Let me scroll it here. Yeah, so it is just a check if it is dividing it completely or not. Now, next comes up our condition, which we have to write, or we can say the statement, which is n equals to n divided by 2. And what does this signifies is we will be keep on dividing our n till it is completely divisible, till when it is completely divisible by 2. And if we reaches somehow our n reaches till 1, it means it got completely divisible. It means it is also one of the factors of it. Then we have to just return, then we have to return true. Otherwise, in else, we will be returning false. So that's how we can easily solve off this problem. So it is like we will be dividing it off, or it is simply like we are doing this step. So it is like reverse engineering. We can say 2 raised to power 4. It means 2 into 2 into 2 into 2. 2 to is the 4, 8, 16. But in the problem statement, they will be giving us 16 only. So we'll be checking 16, if 16 divided by 2 is 8, then it's also divided by 2, 4. It's then again till we will be going till it is divisible. If somehow we get 3 by 2, this model is not equals to 0, then we will not go further in the while loop and our n will be different only. So we'll be returning false. Okay, so that's how it will be working off. Now let's get into the problem statement. First of all, solving of power of 2. So we can need to write anything else. If condition is first of all needed, if our n is double equals to 0, means the comparison operator, my bad, for this curly braces, return false. Okay, but in the while loop, we will be writing it off like our n modulo 2, because we are finding it for power of 2, is equals to 0. Till when our n modulo 2, till when our 2 is completely dividing our n. Whenever the remainder is not equals to 0, we can say when we divide our n by 2. Till then, we have to make our n to be divisible by 2 again and again. So that's how it will be working off, and then just a check, just a simple check condition. If our n have reached the 1, means it got completely divisible, return our true. Else, in else condition, we have to do return false. Okay, so that's how it will be working. Now let's see if it works or not. Let's run the test cases. And here we are. Here it got accepted. Absolutely fine. Let's submit this off and see if it is working there also. Yeah, completely fine. It is working absolutely fine for this problem statement log of n, because what I have told you for the time complexity is whenever we are dividing it off the problem statement, we are dividing it again and again, it will be going for the logarithmic of time complexity. So log of n is time complexity for this problem statement. Let's get into the power of 3. Do we need to do some additions or here and there in this problem statement? Absolutely not. Just a few additions. That is, instead of 2, just writing 3. Now, if I will go back to lead code, here if I will quickly write out the same code which we have written earlier also, if n is equals to 0, then we have to write return, and we return the false, and then writing of while loop, while while our n is equals to, sorry, n modulo 3 is equals to 0. In that case we have to just write n equals to n divided by 3. And then we will be writing off. Then we'll be writing off in a way like if our n have reached our desired case, return true. Otherwise, else return false. Okay, so we will be checking for this also. Let's see if it works or not. It got accepted. Let's submit this off. It got submitted also. So that's how it will be looking. Okay, we have to upgrade. So this also will be having time complexity of logarithmic of n because we are dividing it in the same way. Let's go for the fourth one. But for the fourth one, why not to just copy this and then let's see if it works here or not. This is power of 4. Just copying the same code, absolutely same code. The logic is same. It is equals to 4 now. And here also doing 4. Now let's run this and see if it works here or not. It is working. Submitting this and then here we go. So all the codes are working absolutely fine. Let me recheck it again. If I will submit this right now, it will be working. If we submit it for the power of 3 also, it is working. And if we go for the power of 4 also, it is working. There we are. So I will be pasting all the problem statements in description. Go and check out all of them and try to solve it. So that's all for the video. I hope you like it. I hope you will solve it. So thanks for watching.